Welcome back. In the last session we have begun with a new module, theoretical distribution. Within that we have discussed about the identification of various frequency distribution of various outcomes of a random experiment. And there are three different types of distribution which we will be studying in detail in the future sessions: binomial distribution, Poisson distribution and normal distribution. Today let us begin with binomial distribution. Next area, binomial distribution. Before we go further into the study, we should have a clear picture about the probability of the occurrence of an event. If you toss a coin, we will get head or a tail. If you throw a dice, you may get any of the number ranging from 1 to 6. So it may or may not happen, which is represented by the terms success and failure. Remember, success and failure. Success means if an event, the probability of an occurrence of an event. If that event occurs, it is known as success. If it doesn't occur, that means failure. In that concept, success and failure. So consider an event associated to a random experiment. When the random experiment is repeated a number of times, the event may or may not occur in each of these experiments, just like that coin tossing and throw of a dice. The occurrence of the event may be named as success, and the non-occurrence is named as failure. So every event has two outcomes. One is success and another is failure. If the occurrence of an event is known as success and non-occurrence of an event is known as failure. For example, in a tossing a coin there are two events, head and tail. One of them is a success and other is a failure. If you throw a dice, we can say that getting a 6 and not getting a 6 are the two events. You may sometimes get a 6 or any other number other than 6. So if you get a 6, that is known as success. Means if you throw a dice and what is the probability of getting 6? In that sense only success and failure. So every event is associated with success or failure. Either success or failure in that sense. So binomial distribution is defined as a random variable x is set to follow binomial distribution with the parameters n and p if its probability function is represented by an binomial distribution function, otherwise known as formula. It is known as function of x, otherwise known as frequency of x or probability of x. We can use terms synonymously. F of x is equal to ncx. I hope you know this part, ncx. We have learned in another style, ncr, in case of permutation and combination. We have learned that concept and we are following the same concept in this probability distribution also. ncx into p raised to x, otherwise known as p superscript of x, and q raised to n minus x, or otherwise known as q superscript n minus x. So this is a famous equation, an important equation with regard to binomial distribution. We will be dealing with many questions and cases with regard to this equation. So before we go further in detail with regard to the equations or cases, we need to understand the meaning of each of the terms. Here P and Q, let us begin with that. P always lies between 0 and 1. P means success of an event. So it will always be a value in between 0 and 1. And Q means is represented by 1 minus P. So otherwise we can write Q plus P equal to 1. We have learned about the probability, one of the properties of probability. If you add the probabilities of all the events, you will get 1. Here P and Q is represented by the probabilities of an event. P represents success and Q represents failure. So if you add P and Q, you will get 1. That is a property concept. So we need not have to worry about that. Just understand the concept. Let's come back to the various variables. NCX p raised to x, n minus x. So p and q is represented by success and failure. P represents success and q represents failure. We will come back to that. First of all, x. X stands for number of success and n stands for number of trials. For example, if I toss coin 5 times, what is the probability of getting head 2 times? So how we are going to substitute that values in this case? X means number of successes. Question was like this: I tossed a coin 5 times and out of 5 times 3. What is the probability of getting 3 heads? So X represents what is the event which are under the study, means particularly what was the event, the occurrence of head, how many times? 3. So X represents number of success which are under study, and n means total number of trials. I mentioned that a coin is tossed number of times. How many number of times? 5 number of times. So total number of events or total number of trials is known as n. And out of n you will be studying in detail probability of anything. Either it may be, I have mentioned that coin is tossed 5 times. I can study about the probability of occurrence of 1 time, heads 1 time, heads 2 times, heads 3 times, 4 times, maximum up to 5 times. So n represents total number of trials. How many times I have tossed a coin? That is the meaning of n. X means out of n, how many times a certain event under study is going to happen, whether it is a head or a tail, whatever the situation depends upon the nature of the question. So that is the meaning of x and n. You need to have a thorough idea about the equation as well as the meaning of each of the variables. So we have discussed about n and x. You need not have to worry about C, because NCR, which we have learned in case of a combination concept, that same scenario is used this here, in this part here, NCX. Instead of NCR, we will be using NCX. P of x. P will be the probability of success. That depends upon the nature of the question. We will come to that part with an example, then you will get a picture. P represents probability of success and Q represents probability of failure, and it is very easy to find. If P is 1 by 3, Q will be 2 by 3, right? Because the remaining value 1 minus P is Q, so you will get value of P and Q. We will discuss with an example, then you will get a clear picture. And binomial distribution analyzes whether random experiment is unbiased or not on the basis of comparing the observed frequencies and expected frequencies. Our main problem with regard to binomial distribution is based on observed frequencies and expected frequencies. During the practical main questions, we will be discussing detail this one: observed frequencies and expected frequencies. This is almost similar to a term which we are using in our management area: actual standards and expected standards. I hope you all know the concept actual standards, expected. It is almost similar to the terms observed frequencies and expected frequencies. We will come to that part in one of our future sessions. So why we are using binomial distribution? Binomial distribution is having many application level in research methods or in studying any certain experiments, events which is having number of trials, but it is having a finite number of trials. So binomial distribution is often very useful in decision making in situations in various business, research, etc. Usually in business, in quality control, it is very widely used. It is also used for identifying sampling, inspection of various items with regard to sampling, research areas likewise. In higher studies, you will study in detail the concept of binomial distribution. Next one, applications of binomial distribution. When random experiments has 2 outcomes which can be called success or failure, at least 2 outcomes. So binomial distribution is applicable only in case of experiments having 2 or more outcomes. That is a concept. Probability for success in a single train remains constant from trial to trial. Even if we will repeating the same, the chances of success for a particular event will be the same. Experiment is repeated finite number of times. As I mentioned earlier, coin was tossed 1000 times or 100 times likewise. There is a number 1000 times or 100 times, 10 times like that. That is known as finite number of times. And finally, trials are independent. I hope you know the meaning of independent with regard to our subject. Independent events, dependent events, likewise. I hope you all know the concept. We discussed about that independent events in the previous sessions cases. And that the same concept is also meant the same here also. Next one. Properties of binomial distribution. There are various properties with regard to binomial distribution. Each of these properties are very important. And the thing is, before we go directly into these properties, it's better to discuss each one of these properties while we dealing or discussing various problems or cases. Because all these properties are requirement with regard to each of the cases. So while discussing each of the problems, you will be understanding the concept of each of the probability. But until then, you just go through all these properties, and in the meantime, during the problem area and application level cases, we will be discussing each of the properties, because these properties are important and requirement for computation of various probability distribution with regard to binomial distribution cases. So just go through it. So the probability of x success out of n trials and failure remains n minus x times is represented by the function f of x into ncx raised to p of x and q raised to n minus x. This was the equation which we have discussed in the previous slide. I just repeated the same in here, and this is known as the law of binomial probability, otherwise known as binomial probability law. It is an important law. We will be discussing many cases with regard to this binomial probability law. Next, let us discuss some of the examples, because we have been discussing the theoretical part. So let us discuss with an example, then you will get a clear picture regarding the terms which we have used and the various propertical concepts with regard to the binomial distribution. 8 unbiased coins were tossed simultaneously. Find the probability of getting exactly 4 heads, or second one, no heads at all, third one, 6 or more heads, fourth question, at most 2 heads, fifth one, number of heads ranging from 3 to 5. So first of all, you need to find the various data given in the question and how we can substitute those numerical data into our binomial distribution equation. So first of all, we need to find p, q, x, n. So let us identify those. We know that the probability of finding the binomial distribution case, the equation is ncx, p of x, q of n minus x, and n is 8. In the question, it is specifically mentioned that 8 unbiased coins were tossed simultaneously. So total number of events are happening 8. So n is represented by 8. Next, p means P is represented by the probability of success of an event, and in the question we have been discussing about the occurrence of heads, 4 heads, no heads, 6 or more heads, at most 2 heads. In almost all the question they are discussing about head, and from the beginning of the last module we have been discussing about the probability of head from a coin tossing concept. So we all know that the probability of getting a head from a coin is 1 by 2. So we can say that value of P is 1 by 2. So success is 1 by 2, then the failure will also be 1 by 2, or otherwise you can use the equation Q equal to 1 minus P. P is 1 by 2, so 1 minus 1 by 2, you will get 1 by 2. So we have got P as well as Q. I hope you are getting the concept. So now we have N, P and Q. Next, we need to find X. So for finding the value of X, we need not have to find out any common number with regard to that, because here there are 5 questions, and each of the 5 questions the value of X change. Because in first question it was said that exactly 4 heads. So in that case X will be 4. But in case of second question there are no heads at all. So the situations change. So X depend upon the questions which we are dealing with. So let us go to the question directly. First one. Probability of exactly 4 heads. That was the first question. Exactly 4 heads. So X is 4. So we can write it as P of X equal to 4. The meaning is the same is written in a words form, that is exactly 4 heads. So P equal to P is represented by probability X equal to 4. So the equation was NCX into P raised to X into Q raised to N minus X, and be cautious, N means total number of items 8. C will remains the same. It's because it is a function of a combination. We all know how to find the combination of a certain numbers. So C subscript it is X. So what was the first question? Exactly 4 heads. So X is 4. So here it is 4. See, that is why we haven't written the value of X in the beginning. Except X, we have noted down all other values, because all other values will be the same whatever the nature of the question. But the X differ depending upon the nature of the question. So X equal to 4. So 8C4 into P raised to X. We have already found the value of P. P is 1 by 2. So 1 by 2. P raised to X. What is the value of X? 4. So 1 by 2 raised to 4 into, next one, Q. We also found that Q also 1 by 2. So let it be 1 by 2. But superscript of Q, it is written as N minus X. N means 8. And X means here it is 4. So 8 minus 4, it will be 4. And I hope you know how to solve 8C4. We are not going to discuss about the computation of combination or any of the simple mathematical steps. So I will go directly into the answer. Just go through the computation. If you have any queries or any mistake, please discuss. So 8C4 you will get 70. 1 by 2 4 means you have to multiply 1 by 2 4 times. So you will get 1 by 16. Into 1 by 2 raised to 8 minus 4. 8 minus 4 means what? 8 minus 4, it will be 4. So 1 by 2 raised to 4. Again 1 by 16. So if you solve this, you will get 70 by 256. So you have got the probability of exactly 4 heads using binomial distribution. So first part of this question is over. Second one. No heads at all. No heads means here X we are dealing with the occurrence of head. So no head means what is the value of X? It will be 0. So X is 0. That is why it is written like that. So follow the same procedure which we have followed just previously. 8CX. N will be the same because whatever the question nature, N, P, Q will be the same, but X differ. So in this case X is 0. So 8C instead of X we use 0 into 1 by 2 raised to X. P raised to X represented by 1 by 2. Raised to X means 0 into Q raised to N minus X. Q is 1 by 2. 1 by 2 raised to N minus X. N is 8 and X is 0. So 8 minus 0, it will be 8. And 8C subscript 1, 0. 0 means the value of that one will be 1. We have learned about that property in case of combination. And 1 by 2 raised to 0. So any number raised to superscript 0 means also 1. That is, these are properties, main properties. So note it down. 1 by 2 into 2 raised to 8. So that means you need to multiply 1 by 2 8 times. So you will get 1 by 256. So if you multiply all these, you will get 1 by 256. Next one, 6 or more heads. from now on you have to be very logical while dealing with the question with regard to distributions. P of 6 or more heads means 6 or more. 6 or more means 6, 7, 8, 9, 10, 11, 12, anything. But you have to be very cautious. In the question it is mentioned that 8 unbiased coins were tossed. So 6 or more means how many numbers? 6, 7, 8. Only that up to 8. No 9, 10, 11, anything will happen. 6, 7, 8. So x is greater than or equal to 6 means the meaning of this one is written as x greater than or equal to 6. So it may be x equal to 6. It may be x equal to 6. Or it may be 7. Or it may be 8. Remember the term or. When or comes, what is the sign? Plus sign. Remember. So you need to find the value of x if it is 6, and you need to find the probability if the value of x is 7, and also you need to find the probability if the value of x is 8. Just like the methods which we have followed here. See, for x equal to 4 we have did like this. But in this case, for 6 you have to do like this, and for 7 you have to do like this, and for 8 also you have to do like this, and you need to add these 3 because it is said that 6 or more. So 6 or 7 or 8. So 6 plus 7 plus 8. That is how you have to do it. So let us do it. If it was a case of x equal to 6, so it will be written as 8c6 into 1 by 2 raised to 6 into 1 by 2 raised to 8 minus 6. Just follow the same step which we have discussed earlier. See, we have discussed the same case previously. So 8c6 you will get 28 into 1 by 2 raised to 6, you will get 1 by 64 into 1 by 2 raised to 4, because 8 minus 6 you will get 4. Sorry, 2. So 1 by 2 raised to 2, 1 by 4. So if you solve this, you will get 28 by 256. We just found the value of probability if the x is 6. Likewise, you need to find 7 and 8. So P probability of x equal to 7. Just like the same method which we have discussed earlier, 8c subscript 7 into 1 by 2 superscript 7 into 1 by 2 superscript 8 minus 7 equal to 8 into 1 by 128 into 1 by 2, you will get 8 by 256. So we have solved the value of x equal to 6 if it is a case of x equal to 7. Next one, x equal to 8. 8c8 into 1 by 2 raised to 8 into 1 by 2 raised to 8 minus 8. 8c8, the value will be 1. It's a property, another property. If these two numbers are same, the value will be 1. 1 by 2 raised to 8 means you need to multiply 1 by 2 8 times. That is 1 by 256. 1 by 2 raised to 8 minus 8 means 1 by 2 raised to 0. Any number raised to 0 will be 1. That is the properties with regard to probabilities. That is why. So you will get 1 by 256. And remember, it was a case of probability if there were exactly 6 or more heads. 6 or more heads means 6 or 7 or 8. We have found 6, 7 and 8. So 6 or 7 or 8 means 6 plus value of 6, 28 by 256 plus 8 by 256 plus 1 by 256, you will get 37 by 256. So next one. At most 2 heads. Next one, at most 2 heads. So by the term at most 2 heads, it's another term, tricky term which we have to remember. Whenever a number associated with at most is given, so here for the example, here it is at most 2. So at most 2 means numbers including 2 less than 2. So numbers 2 including 2 means numbers. What are the numbers less than 2? It will be 0, 1, and at most 2 means including 2. So the numbers will be 0, 1 and 2. So at most 2 heads means it might be no heads, that means 0 heads. It might be 1 head, or it might be 2 heads. That is the meaning of at most 2 heads. So just like the 6 or more heads, you need to find the probabilities of 0 or 1 or 2, because it is written at most 2 heads. And at most is given, whatever the number associated with at most, you need to take the numbers less than those number given. Here it is at most 2 means 0, 1 and 2, including 2. That is meaning. So you need to find the probability with regard to 0. That is x equal to 0. I think x is equal to 0 we already found, and x equal to 1 and x equal to 2. Here it is just another example. Here the coins is given, 8 unbiased coins, so 1 0 occurrence of head will be 0, 1 2 3 4 5 6 7 8 likewise. You don't go with the actual values given here, just understand the concept. What were we discussing? At most 2 heads. At most 2 heads means if x equal to 0, x equal to 1 and x equal to 2. So you need to find the probability of x equal to 0. So for x equal to 0 you will get 1. Actually it is 1 by 256. For time being just understand it is 1. 1 by 256. That is the correct answer. It's another case, that is why it is written like this. The computation is just like this, x equal to 0, so x equal to 0. Here it is 0.5. 0.5 is the fraction of 1 by 2. You can either write 1 by 2 or you can write 0.5, anything. That's your convenience or discretion. So when x equal to 0, answer is 1 by 256. We have already found the value of x equal to 0. Next one, x equal to 1. X equal to 1, you will get 8 by 256. It's another question, that is why it is written 8. 8 by 256. And next one, if x equal to 2, the value will be 28 by 256. So now you have got the values of x equal to 0, x equal to 1 and x equal to 2. So the values is 1 by 256, 8 by 256 and 28 by 256. So you have got 3 values. How you are going to find the probability if the case was an at most 2? So at most 2 heads means you might get x equal to 0 or x equal to 1 or x equal to 2. So just add all these 3 numbers, 1 by 256 plus 8 by 256 plus 28 by 256. So you will get the case of at most 2 heads. And next one, last one was the question, number of heads ranging from 3 to 5. I hope if you remember the question, that was it. We are not going back again for checking that one. The question was like this, number of heads ranging from 3 to 5. So number of heads ranging from 3 to 5. How many numbers are there in between 3 to 5? That is 3, 4, 5. So numbers will be 3, 4, 5. So what is the probability that you are getting a head? Means you might get 3 or you might get 4 heads or you might get 5 heads. That is the meaning. So probability of number of heads ranging from 3 to 5 means you might get 3 head situation or you might get 4 heads situation and you might get 5 head situation. So 3, 4 and 5. 3 or 4 or 5. So if it is x equal to 3, then you will get 56 by 256. If it is a case where x equal to 4, it will be 70 by 256. And if it is 5, you will get 56 by 256. And the question was number of heads ranging from 3 to 5. So the numbers are 3, 4 and 5. So it may be 3 or it may be 4, it might be 5. So that is the concept. We will discuss about the advanced question with regard to that. Just now understand the concept of NCX, P raised to X and Q raised to N minus X, and how we are going to identify the values of X, identify the values of N, P and Q. Just understand those concepts. Just go through it. We will discuss in detail about the advanced cases in the coming sessions.